Well, hi, good morning. Thanks so much for joining me here in my shop. So I'm at the same point right now where I was yesterday when I started, and that is I want to hook up some test equipment, monitor the operation of the radio, find out if I can any specifics around its current misoperation, and then proceed to make changes in the radio and see what happens to the radio as I go. So I just want to kind of have the X-ray equipment running while I'm poking around with it. Yesterday I barely got going, and I found a serious problem. As you know, if you watched the video, you know there was a cut wire down here. Ultimately I simply soldered it back together, and presto, the main problem I was going after first, which was this cut off problem in the radio where it appeared as if tube biasing was such that one tube was being cut off or driven into cut off. Well, that all went away. So that's great. That's one big problem gone. Glad I found it, because that's the kind of thing you could hunt for a long, long time. The only thing worse than that is an accidental ground or short circuit between two components. Really hard to find. Anyway, so here we are. So I started today. Haven't gotten very far yet in hooking up test equipment. Mainly the SDR is what I'm interested in getting going on here. When I've noticed an interesting variation between the two radios. These two radios, they look pretty darn identical, but there are some subtle differences in them. I'm going to show you one, and I think I'm going to do this with paper. I think I'm going to do it with the close-up camera here, so just bear with me, because the printout we're going to look at is not the best. So here we go. And I'm going to have to get a little pointer here. So the first thing we're looking at is the schematic for I want to start with this radio here. So this is the one I finished already, the 535, not the one I'm working on. I'm going to go right up here, and we're going to take a look at this tube. Oh, for crying out loud. Look at my lighting. Let me hold it up like this. Okay, this is kind of a crude way to show you this. If I could stop shaking, that'd be good too. So look at the plates. Look at the two diode plates in there. Oh, my heart's going a mile a minute here. Bum, 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 bum. How do you like that? See how they're just simply connected together as if there's only one diode plate in there. And then you can see the rectification occurs between the cathode and the plate coming from the secondary of the transformer there. And there's a couple capacitors in there for fun and pleasure, I guess. Now we'll look at the other radio. It's the same tube, 6Q7. Take a look at the style of writing here. It's handwritten, so you can see the person's style of writing. See where he says second detector. Now let's switch schematics. This is the radio I am now working on. Okay, same tube. First look at the writing. It's exactly the same guy. It's the same draftsman doing this. It's the same writing. Come down here. Oh, see the two diodes? Look how different they're showing now. Now, what exactly is he showing there? So, man, I'm just so, wow, I can't believe how shit. It's because I was running around a little bit, I think, just before I turned the camera on. Shouldn't have been doing that. So, you can see these are now separate. One is hooked this way, and the other is hooked that way. Or. That's 4 ors, wasn't it? Four ors. Or is this connected here? It looks like it's connected here. It's just grounded out. In this radio, they show it grounded out. I think that's what this really shows. I don't know if you could do like a push, I was going to say push-pull. If you can do a full wave rectification here, have both these diodes hooked to the transformer. I don't see why you couldn't do full wave rectification at this point. I have to think about that for quite a while, because the objective of the detector is to chop off one half of the signal, leaving the other half to generate a potential difference at the audio frequency, which it can't do with both halves of the signal there. Or can it? I don't know, I have to think about this quite a bit. I think the point is, in my head was this. Okay. Which really means you can hit either pin on this tube for either of these plates. They each have their own pin, and you've got them both the same way. But in the other tube, this one appears to be grounded out down here. It's really drawn quite differently, isn't it? And why couldn't, maybe otherwise they'd look identical. These circuits look identical. So why the change? I don't know. Is there a change? I don't know. Is this right or wrong? I don't know. But one thing's for sure, I have a chance of attaching my equipment to what I think is a pin doing something when it's really not, because of these inconsistencies in the way these two radios are done. Even though it's the same guy, it's the same guy. 1930, this is about 1940, this radio, 4041. So if the person who drew this was a junior guy in the engineering department, that's usually the case. He's probably 25 or 25 years old. So 25 in 1940, 80 years, he's 105 years old now. And we're looking at his work. And unfortunately, and very few of these schematics is there a signature that's preserved, like a title block and a signature. But the odd one does actually has the full round of signatures. You know, who drew it, who checked it, who's the engineer in charge. Okay, so I have a bit of a background in engineering drawings. I get a little fascinated, overly fascinated by this stuff. But that's just another example of how easy it is to overlook things that are hard to spot on these schematics. And it could lead me to doing something dumb. So in this radio, one plate is connected and the other plate is grounded. The reason I was looking at this, I didn't even say that. I'm getting ready to hook up my SDR, so I'm examining the tube arrangements very carefully, especially up here. I really want to attach, I really want this arranged so that scope is looking at output of the IF, SDR is looking at input to the IF, or output from this tube, and whatever else the SDR can see. I want to make a fairly high impedance connection up into this circuitry up here. So I'm going to use a fairly large resistor to pad away the SDR from here. And something else I've done, by the way, if you watch me using my SDR, you must realize how nervous I actually am that I'm going to blow it up. I don't care that much. It's a $25 meter, and if I sacrifice it in the course of learning something, I'm going to buy another one. $25 is not going to stop me from just getting another one. I don't want to blow it up. So the thing I'm worried about him blowing this up is hooking it up to a large DC voltage in the radio here, and that might be the end of it. So what I've done in this little box goes with Tektronix scopes. In here is nothing more than a very small, I think about like a 10, I think it's a 60 picofarad capacitor, come to think of it. 60 picofarad, just from the conductor here to the conductor there. And of course the outside part is just straight through, like that. So I'm just introducing a capacitor to block a small capacitor. Small capacitor charge quick. They put a big capacitor in there, and the charging up process may allow the voltage to still strike your radio dead. So I put a small capacitor in there, charge up quickly. Hopefully I'm much safer now. Now as for the resistor I need, and the point at which I want to clip it. Okay, well unfortunately I got a little more to talk about on here. So just another interesting thing I've noticed. So the top of the volume control is here, and that's where you want the audio signal to end up. You don't want any DC, so you stick a capacitor in, right? And then you take the signal from the detector in the secondary coil here, right here. Wait a minute. Well, this doesn't connect. We follow this, the output from the detector stage comes down here, big resistor to ground, so it's as if this doesn't exist. The signal comes along, heads this way, we won't talk about that, but look at it, it comes up here. Oh, and reaches this terminal strip that's mounted on the back apron of the radio. This is exposed to the users. of the radio. Can you see they've drawn a link in there? There's a metal link that really exists between these screws on the back of the radio. And then the signal continues back into the radio. Well, it never really left, but at least from this terminal on the back of the radio, continues down. Now the thing I want to show you is almost certainly this schematic was drawn without this piece in it at all. This piece came straight across here. Look, the wire, everything lines up. In a subsequent revision, when they added this in, so you could hook it up to your TV or phonograph, this is phonograph terminal board. So they erased the line here, then stuck additional lines in. They stuck this line in. It's in kind of an awkward place here. They put this up here, then they drew this line, which is even more awkward. Now when you stand back and look at this, you can see that this was all added in afterwards. I've been watching too many programs on ancient structures like pyramids and whatnot. They go around analyzing the rocks and the bull rocks, the big blocks of rock, you know, the 100, 500-ton blocks of rock, and they say, look, you just look at it and think about it, you can tell how this got to be the way it is. And the same thing here. There's probably more revisions we could pick up in here. You can even tell the line control here isn't as good. This is a bit of a fat line here he's drawn. This one too just doesn't look quite as neat as these other lines. I mean, this is a photocopy of a reproduction and this and that, so it's really pretty poor to begin with. So the DC part that we're interested in getting on the scope exists all the way through here, all the way up here. You can get it on the back apron. I can actually hook my scope up to this if I want, to this in the ground here. It's not blocked till it gets here. And from here, you have no DC. That results from the detector operation. And of course, they got this arranged to produce a negative voltage relative to the chassis, which they then shoot back through these resistors to, I'm sure, it works its way out to the grids of these other tubes back here. So, just wanted to show you that, how that works, and tell another drafting story. You know, I make this stuff up. I don't really know that it's true. I make everything up. Okay, I think I got wires put on properly here. So what I've got is scope, both channels of the scope connected. One is to the speaker, and the other one is to the output of the IF, picked up on the back apron here, as I was explaining earlier. And then I've gone ahead and I'm utilizing my decade resistance box up here. It's crazy long leads coming out. This is connected to the output of the mixer tube, or converter tube, or shifter tube, whatever you want to call it. Or as they call it in this radio, they call it the first detector tube. So it's got many, many names, but in North America we tend to call this a mixer tube. So the output should show lots of different signals, and it should show up on the SDR. Okay, so I need to kind of turn on the radio and convince myself that this is a setup that's not throwing the radio off itself. And I think I'm pretty sure what I'm doing now. And we're going to get some really good views on this radio. So I believe. So I have believed many times, only to be fooled. Okay, next step. Okay, so here's what I'm doing with the sweep generator. I'm going to make it sweep through the entire AM radio band. So it's going to start, this is the start frequency, just below 530. 530 is the bottom of the AM band. And it's going to go all the way up to just above 1700. This radio receives 1700. Yep, just took a look. And it's going to be, we're going to start it sweeping quite slowly here, so we can see the sweep and sort of reassure us of how things are working. So it's 1 second now to sweep through the band. And it's stopped right now, so it's not sweeping. That's what that guy's going to do. These are my level controls. Feeding this signal straight into the antenna on the radio. Nothing fancy happening there. And I'll just adjust the level here. Usually takes quite a strong signal to get this guy to work. Meanwhile, on my scope, you see dual trace set up there. And so this upper one is the speaker. So that's what the speaker is producing, and this will be the output of the IF here. So turn it like that. That's the theory, anyway. So here we'll see nothing here. You know what? We should see virtually nothing here because the signal I'm using is not modulated. Come to think of it, there is a wumping sound that comes out of the speaker. We might see the same pattern here that we see here. It's possible. Hey, that's kind of neat in itself. Seldom do I use the dual trace capability of my scope. So, okay, and what else have I got on the go here? I don't think I have anything else on the go except I got to get set up to show the SDR. Whoops. Okay, let me get that going. Okay, I think we're pretty set up now. So you see, I've got the dual. I got so much stuff here. Goodness knows, everything's going to go wrong. So I got the dual trace happening here. I've got the SDR happening there, and I also have access to some audio analysis software here. So we can look at what we're hearing and what the radio is doing in a number of ways. This should give enough insight into sorting out. Well, I don't know. Let's see what we sort out. The SDR isolation resistance is set really high right now. It's 1,000,000 ohms. So the SDR antenna is basically hooked up to a 1,000,000 ohm resistor before it makes its connection to the output of the first detector. Oh, spot with 2 capacitors coming off of it. Wow. There aren't 2 capacitors coming off of. Should be no capacitors. This should be going straight into this IF coil. It should be like basically a straight wire from this socket right into the first IF. Well, okay, well, let's take a look. Let's take a look. This is going to hurt a bit because I'm going to use this camera here. Ouch. The set is off. Once again, this is more for my sake. I do something. I think I've got it on autofocus right now, so this might be a bit of a hassle too. So this green capacitor and the red one down there, the 2 leads go down to the same terminal. That's the terminal I clipped on. Now, is that the right terminal? Because there's another capacitor coming off it, that mica one. So, well, what have I done here? Maybe I've hooked it up to the wrong pin. Give me my, where's my counting stick? Okay, let's see if I can do this on camera. I'll do it a different way. Maybe I'll, different way, get a different result. So let's see. Tube we're looking at. We're looking at the correct tube. And we're looking for the key on the. There's the key. There's the key. So it's pin 1 to the right, pin 2 to the left, pin 3. I guess do this one. So pin 1, then pin 2. Pin 2 is no pin. Pin 2 is empty. And if we look at it from over here, you can see the empty one, and then there's pin 3. Pin 3 has these 2 capacitors connected to it. And the mica capacitor. And I think that brownish wire is passing by, and then there's a resistor. Oh no, the resistor is passing by also, isn't it? No, the resistor is connected there. What's happening? What's happening to pin 3? You know what's happening? I'm looking at the wrong tube. I'm totally wrong here. completely wrong. What a mess up. So, you know, the tube I'm looking at is totally the wrong tube, Jim. Come on, man. Okay, let's go where the business really is. Duh. Oh, well, that explains everything. Here, let's try it here. Okay, pin 3. There's pin 3. Pin 3 is a wire that goes straight to that IF can there. That's it. That's it. That's it. Oh, what a dummy. Okay. Let me clip in there. What a dummy. So in the back of my mind, I was remembering the last radio I did, the same basic type of radio, and I remember the clip being way down below here, but anyway, who knows. Yeah, my memory. That's right. Told my wife a childhood memory last night when I was done. I said, of course, none of that probably happened because from what I understand, we cannot trust our memories even though we might be convinced that we're remembering something, absolutely convinced. We would testify in court and everything. No, it didn't ever happen. So I have some nice childhood memories, but I must force myself to doubt them all. Now, I think we're ready this time, so let's boot the isolation way back up. Let's put in that little capacitor back in the line over here, because I really do want to use that. I'll make that a standard piece. Sorry. Do a little shock testing now and then. Put this in here. Okay, we're connected over here. We're into here, onto the ground. Isolation up above is set for, I'm going to get rid of the capacitor setting, just the resistor. 1 million ohms. 1 million ohms. Okay, are we ready to go again? I think we're ready to go again. Here we go. Power. Let's go power on here. Dim lights work properly. My cats haven't bothered me yet today. Okay, watching the scope. And it's coming. Oh, it's very weak. Much weaker than it was, and that's probably because I'm zapping out some of the energy to go to the SDR. The SDR is not showing much. Let's see. Local oscillator visible. Oh, there he is. Okay, so what we'll do, we're going to increase the isolation here. We'll take it up to 5. This is 5 megohms of isolation. The signal's still tiny coming out of the radio. Is that really because of what I've done? I'm looking at the I think it is tiny. Okay, so I'm going to disconnect this. Oh, not much change. Not much change at all. So that's the SDR going on and off. And notice the not much there. Something else I did? Give it a little more. Okay, so turn up the signal generator. Okay, scope is good. SDR, what are we seeing on the SDR? Let me tune. Okay, local oscillator perfectly visible. Let me tune the radio to, okay, so we're tuned around 600. So if you look at 600, very close to where the red line is, look for something moving. Yes, there is something moving. It's hard to spot. It's right on the 600 line now. Little tiny peak there. You see, I got my hand on the control, so I know what I'm doing with it. So I'm able, in a sense, to be aware of two things at once. And you can't. You don't know what I'm doing with my hand. You can't watch both things. See it just crossed the red line. Just watch it moving to the right. It's coming up on 700. I'm going to stop it at 700. Right there. I'm going to look at the radio dial. Oh my gosh, the radio dial is going the other way. Oh, okay, so that's not... Once again, I am awash in irony. Okay, so let's put this on something easy. Stick this on 1 million. The radio is now tuned to 1 million hertz. The local oscillator appears to be right around 1460. Let's just click on it here. So let's click on it again. It didn't go. There we are. So 14,455. That's not quite on there. So what we've discovered is the local oscillator is running at 1453 when the radio is tuned. Let me just make sure it's exact now. The dump pointer's right on 1 million. Yeah, that's not bad. That's all lining up pretty good. So now we'll look at the SDR right around the 1 million mark and see if we can see a little bit of the front end. I'll make it move by tuning the radio back and forth. Right around 1 million. I don't see anything moving around 1 million. I can really. So that's going down. Well, you can watch the local oscillator to know which way I'm tuning. And then up. Right back to the 1 million mark. So I cannot see the front end, but that could just be because I'm not giving her enough. So let's give her lots more here. Okay, now I'm really giving her a whack. Turn the radio down. Oh, that was actually turned up quite loud. Now all kinds of things have shown up on the SDR. So local oscillator, still exactly where we had it. I'll put it back. At 1 million, you now see the front end tuning right around 1 million, and if you look at the left, you can see right at 460 the peak, and that's most certainly the IF. So there we are. We have all. So we have these three factors shown. Now, when I say the IF, okay, a couple of you picked up on this in my other video where I was doing this work. And I mean, this is an odd thing here. I'm not after the IF, I'm at the doorstep of the IF. So it's a little like standing outside of a room, but seeing what's going on inside. It's a little bit like that. It's kind of weird. How do you know what's going on inside the IF when you're actually at the front door, outside the front door? And the answer to that, I believe, is what we're really seeing is the resonant point of the IF, first IF primary coil, or the whole transformer. I'm not sure how to interpret that. So if we tune the first IF way off, this peak would move in accordance with where we tune it, but the output from the IF, which we're seeing on the scope, would not be affected the same way. In fact, I think it would just decrease. You would just see a drop. But on the front here, I think what we're sensitive to is the tuning of the first IF. I click on it here. 458, 460, it's dead on, dead on. And this is on 1 million, this is coming right up, dead on. So the radio appears to be very well aligned, at least at this one place on the dial, which is in the middle. So now we'll take it down, we'll do the same study here, we'll go down to, let's say, 560 would be a good place to go. Down to 560. So I'm watching the front end peak. It's right around 560. So I'll look on the dial of the radio now, and I'll make sure it's right on 560. So it's actually on 570. Put it on 560 exactly. Okay, so that's 560. Now, let's see. I just click here and the SDR will help me measure this. So we're very close to 560. A touch off. Okay, next thing we want to measure is the local oscillator. The local oscillator should be, I should have picked 540. This is tough math for me. If it was 540, 460, 1000, so it should be 1020. 1016. Wait a minute, we're not quite on the money here. There. 1017. So that's the same error, if you like, as what we see down here, slightly, and that makes sense to me. And then the front end, that is the front end, right, righto. So I think what this shows is at the lower end, the radio is also aligned and working well. We'll go up to the upper end now. A little funny happened on the scope there. So probably lots of weird things on the SDR too. So probably what happened is I'm going past the limit of the sweep. The sweep, right when I do this, I think that's what's happened. Looking at the scope. Stop frequency 1704. I don't think I can move it up any higher. Wait a minute, yes I can. Sure I can. 17, so I'll make it 17, make it 18, make it 18. Okay, so I'm setting this to be 18 here. Alright, I reckon up my camera shot totally. Just about every video I shoot, I'm trying new things video-wise. And a high percentage of the time they aren't so good. Okay. Let's get this thing sweeping again. Now, looking back at Mr. SDR, a local oscillator is way up here now at 2030. This peak appears, if I pick the middle, it's a little tricky here. The wave shape on the SDR is distorted by other signals that are added in, if you like. So, I don't know. We'll pretend that's the middle. 1570. Okay, what am I really tuned to? Let me tune it to exactly 16. 16. That's 16 there. So to receive at 16, you should have a local oscillator running at 2060. Wouldn't that be what it is? 2060? 2040. Did I do something wrong there? Let's try that again. So we're tuned to exactly 1600. So it should be 1600 plus 460. 2060 or 2040. Okay, and so it looks like it's a little off. I think that's the best I can say. The dial is set to 1600. This appears to be peaking certainly in that area around 1600. This peak isn't necessarily so sharp that it selects out 1600. It's a bit of a thing to it here, slope. So even if this isn't dead on, as long as it's not down here, that'd be good. But the fact is, we're not tuned to 1600. In reality, the local oscillator is at 10, 20, 40, 20 kilohertz below where we've aimed. If I've got this right, the radio is actually tuned to 1580. It might be 1620. I may not have done it quite right. So it's a little bit out up here. And looking down here, why there is such a powerful signal here. So this is coming out of the mixer tube. This great big signal here. It's a whopper too. You know, this is I think this is a decibel scale here, I think. Wow. That's, if that is, then that's 25, and the other signal here, which is the real signal, as I would put it, is at 35. That's 10 decibels. That's quite a difference. Seen this? I saw this on the other radio too, I believe. This double peak thing, I never really dealt with it. So I don't know what to make of it. Let me tune the radio a bit and watch what happens to that thing. Tune back. I reached the end of the limit here. In fact, I may have gotten out of the sweep zone again. Just tuning along and watching that thing. There's a couple possibilities here. One is there is actually a powerful signal in my house at that frequency. That's really interesting because that's close enough and you can see what it's doing. It's getting into the IF. The 460 spot there just always shows something, and that would be the sweep going through it. Because remember, the radio, because of the sweep, the radio is receiving a signal everywhere on the dial. The signal is sweeping by every spot. Well, that's really interesting. Let's investigate this a little further. I have nothing better to do with my time. What is this? Let's listen to it. We can listen to it using the SDR. So, whoops. The SDR just shifted the display over. That's all that happened there. Automatically. So here we are. So now we're tuned to this thing at 378. Let's listen to it. Wow, that sure sounds like the sweep generator. Let me turn off the sweep generator, or I'll just stop the sweep here. That's really interesting. Now there's something left there, just to the right of the red line. There's a little peak. Tune the radio a touch. So that peak's going nowhere. Okay. I need me more radios in here. 390. I need some more radios. Quick. More radios. Okay, so I ran out and grabbed another radio, but it won't tune down this low. You know, this is kind of an unused radio band. Not really, but sort of. So I'm going to use the SDR, and what I'll do is I'll disconnect it from the radio and hook it up to just something. I have something here, just basically an antenna in my shop, and we'll see what it picks up out of the air at the same spot. It was 390 and 387, wasn't it? Was it? Can I remind myself? Oh, put the sweep back on. That's what I need. Right, this sweep thing. Okay, so the sweep thing, this thing here, this spot here, disappeared. 379 disappeared without the sweep. This other thing right here remained. And then this is the IF peak here. 455 probably. So with this disappearing, and plus it sounded, when we listened to it, it sounded like the sweep. So why 2? I saw this in the other radio. Why 2? You know, one thought is, well, one IF transformer is tuned here and the other one's tuned there. That doesn't make sense on the IF. You could see that on the scope at the output, but at the input you can't see problems inside the IF. So, and coming out of the IF, we don't see any of this. We do see some of it. Yes. That's got to be what this little peak is. Is it? Is that what this is? Is that what that? Is that? Okay, back to what we're going to do now. So I'm just going to unplug the SDR from the radio and plug in basically an antenna here in my shop. Let's watch the scope as I pull this out because maybe it's going to reveal something about. Come on out. There. Nope, scope didn't change one iota. Okay, we'll hook up just a general piece of wire antenna here to the SDR. Okay, so is there something happening there? No, there's no 387 signal. You can consider this just the noise of my shop. So you see a little something here. What's that sound like? Not much of anything. You know, this is an awfully low signal for, you know, that little capacitor still in here. Hey, I'm learning as I go. Maybe I'll get rid of this little capacitor here because maybe it's just knocking out the, it's too little. I'll hook the antenna up straight. See the difference? It's 387, isn't it? 387. What do you see there? Yikes. That's me grabbing the antenna wire and letting go. So, you see there are some signals down here, and if we look at the 460 area, nothing really in there, but there's something right here. What is that? Just some noise. So that's a radio station there, 590. You can see the mirror. 590, 610, 640, 680. This is 640. 610. If we click on any of these signals and they come out to a nice round number, they're probably a station. See that coming out to 740? See the next one up here? Let's look at the next one. It's right on 750. I don't hear any station. I don't know of any station at 750. Let's try these. These ones are going to work here. Let's try this. Okay, so that's Funny 820 we're listening to. That's a comedy channel. Plays comedy records all 24/7. There's another geek, a little one just beside it. Let's go find out the frequency of that. .816. Well, there's no AM station at 816. That must be a noise signal. .750. I did this one already, didn't I? 740. So that gives you the spread. Huh. The SDR, I'm using it as a radio right now. It's really hooked up to a really lousy antenna, but look at that. This is nice. I'm picking by a factor of 10 kilohertz, and if it lines up, it's a station, almost certainly. Now that's noise. See, it doesn't line up. That's noise. What noise? Who knows? It's right on 1140. I don't know that there's a signal there. It's just a coincidence. Okay, well, that's another interesting way to use the SDR here to identify noise signals in your reception area. Radio, radio, radio. Come on. Radio, then there's noise just to the left of it. Radio, radio. Commercial. Wow, they're all here. Oops. $4.90. Oops, I must have bumped it. So the thing about that 490 signal is it's pretty darn close to the IF frequency of 460. Don't remind me of the weather, please. It's a gray, rainy day all day today. Okay, that's lots of fun. One more thing. What about the shape of the response curve? So we look at the scope, we see the output of the IF. The scope currently is sweeping in a non-logarithmic mode. And my imagination says that may distort the shape of this. So what I want to do, I'm going to change the set. There's a little tiny there too. So there's that, the main one, and then this thing way up here. What I want to do is I want to move this into the center of the screen and widen it out. So to do that, I'm going to cut the stop frequency where it's out here at 1700. I'm going to move it to 1500, 1600, 1400. As I do that, that will make it doesn't move back. Instead, the line will stretch this way because the end is always the end. The end is always the end. So what did I say I was going to do? Cut this back. Here we go. Wait a second here. Okay, that's better. We'll stick it in the middle so we can get a better look at it. It's a little wider out here. It looks fairly balanced, doesn't it? We can widen it out further. We can move up the start frequency and move down the stop frequency. There we are. We got a much better look at it. Still see this front thing, which we don't know what the heck this is. Could just be an artifact of my testing. We can see kind of the curve coming down here. We can see there's a fair bit of RF in the signal here. It's quite apparent. That's why it's wide. And back up. This is essentially I was going to say this is essentially an audio signal. No, I don't think I can say that. I don't think that can be said at all. Yeah, rub that out. So now is this looking pretty good, or is it a little distorted over here? Does it even matter much? I mean, it's nothing terrible about it. It's not clipped off. It's not terribly out of whack. So I think the response curve shape looks pretty good. I'm going to switch my sweep into a logarithmic mode here. Wow. Didn't that just do the trick? No experience with doing this, so just give me a second. See if I can't get this to behave. I cannot. Okay, so I don't know exactly what happened here. Let's put it back the other way. Put this back in the middle. I was thinking if I run so the sweep is steady across here. If I run it logarithmic, which I think goes zoom, zoom, we can imagine what that happens. If it's sweeping here slower than it's sweeping here, then this will be pulled back a little bit. We'll sharpen this up just a little bit. So it could well be that if viewed in a logarithmic mode, this shape is perfect. So we got the IF shape, response shape, and we've got stuff at the front end of the radio to look at. I think we're ready to go. This only took me nearly forever to get to here. So what I mean by ready to go, now it's time to start poking around with the radio, change some parts, change some other elements in the radio and its operation, and watch all these things change or improve or whatever it is they might do. Come to think of it, really the first thing I want to do is clear out the audio area. I've set this whole thing up for doing the RF side. So that's what will happen. Tomorrow I will reset this to focus more on the output from the speaker, and then we'll fool around with we'll start fooling around with the audio circuits, capacitors mainly, and see if anything improves in that. But anyway, at least at this point, I've identified how to make the connections into the radio to produce the right kinds of things on my screen. So I'm aware of the effects that are going to take place while I'm doing changes when we do the RF side of it. But I really do want to start with the audio side. Maybe it makes sense to check this out like this first and be aware of how the radio is working generally before you start going in after audio stuff. We could do one last thing, but I won't because I've been in here too long already. I'll save that for tomorrow. I was going to put an audio signal through it. Let's save it for tomorrow. Let us save that for tomorrow. Thanks a lot for watching, and sorry I kind of chugged my way through this, but I got to get into a position of knowing the truth. That's what I love about engineering, by the way. It's founded rock solid on the truth. Engineering and science is a hunt for the truth, and I love that about it. Okay, see you tomorrow.